So I'll just do the presentation for the Energypod. Yeah, okay, perfect. So yes, we've put together a bit of information about the Energypod, the process of installation, the process of commissioning, and also a few health and safety elements to account for, in particular in relation to the fact that it is a compressed system with R32 inside. So there is a few consideration that needs to be taken into account when the system is installed. And I'll go through them today. So for the people that don't really know what the Energypod is, so the Energypod, the aim is to deliver energy through thermal to the entirety of the flat, through the management also of the air CO2 level inside the dwelling. And it consists of 3 different parts, which I'll cover just after, which is the heat pump module that weighs about 35 kilograms, the air handler unit at 100, it's the opposite. The heat pump module is 100 kilograms, the air handler unit is about 35, and the thermal store is roughly around 135 kilograms. The main point to account for during the installation is the connection of the water supply of the house to the Energypod. It's really important that this 22 millimeter male BSPP fitting is or an adapter is supplied on site. We had an experience where we installed an Energypod on site and the installer didn't know what the sizing was. It was back in France. And in France, it's not something that you can supply quite easily. It needs to be ordered. So that delays the installation process of about 2 days. So it's something that needs to be accounted for when the installation planning is done. The connection to the air circulation in the flat and on the outdoor air draw is a 125 mil connector. So you can just put a spigot on top of it and then connect it to the air system. The supply is a 32 amp electrical cable. We have a fuse inside, which is 132 amp. So we need to have the appropriate sizing in terms of power supply to the system. So you can see the system here on the left, which is the 3D model. And on the right, you can see the system which was packed before it was shipped to France in the scope of another project, which we were working on, where we developed the technology from a very low TRL to a bit more recent. So you can see the packaging over there. The height of the heat pump is about 2.3 meters, and with the 600, and the depth is about 629. So it's quite a bulky system. So that's why we need to give you all the information necessary for you to be able to handle it properly once you're on site. So the 3 sections look like this. So the handling module on the left. So this is taking care of all of the circulation of the air in the property. The refrigeration and the hydronic module. So this is the heart of the heat pump, really. It has the compressor, has the control system, and it also has all of the water circulation system, pumps, valves, etc. And then finally, the thermal storage module, which is basically a large square with a PCM inside. So this is where most of the weight of the system is. And we put that at the bottom. So that allows us to have a very low center of gravity. So when you do transportation on site, you don't have any issue of tipping, which is something that can happen with very large, tall system like this with a very small footprint. The center of gravity of our system is very, very low to the ground. So there is very low chance of tipping during operation. Now, looking at the transportation on site, there is a few things to account for. So the first one is the heat pump will come in a single packaging, like I showed you on the photo. However, there is a potential to separate the units. So I'll show you the 3 different sections can be separated. We just need to be aware of that you are doing that, and then we'll give you a proper process for this, because currently we're not envisioning that in the project. And again, if I take the example of DC2, for example, well, we won't need any pallet truck or stair climbing crawler or anything like this, because we're going to use a crane to take the system up. So in the case of the DC2, for example, it will be a very simple installation. The system can be just strapped onto a crane, and then the crane can lift it inside through the roof. But if we look at the Spanish site, for example, which has different floors, etc., in this situation, we advise first for clearance along the path of the installation. So just make sure that there is no obstacle, and just make sure also that the 2.3 meters of the heat pump can fit anywhere. What we want to avoid is that you start moving the system and then you see that, oh, I don't have a clearance here. I have a system that is almost 300 kilo. I am in very difficult, very dangerous situation. So the clearance is vital first before moving the system. If you have any, you need to identify if you have steps, ceiling, low ceiling, obstacles, and things like this, and then you can select a suitable handling unit system. So here, for example, in the case of if you don't need to disassemble your unit and you're installing on the ground floor, a pallet truck is more than sufficient to move the system with at least 3 people to make sure that it doesn't tip. So it's very important during movement, it could tip, but just to be safe, do not handle it on your own. The second one is the stair climbing crawler. So the stair climbing crawler allow you to take the system up the stairs fairly easily. It can handle very large weights. So make sure that the system is also sized for the application. So I would recommend at least between 500 and 750 kilogram stair climbing crawler, just to make sure that you have no risk of any slipping or anything like this. Also, just make sure that you're aware as well how to use a stair climbing crawler. Of course, no one should be behind the crawler in the stairs, just in case you slip, and then you have a risk of crushing, basically. In case of a system that is disassembled, well, again, and you have to take it upstairs, again, use the stair climbing crawler. It is the most safe way to do it and the easiest way to handle our system. In the case of disassembly, then once you put all the parts in the flat, you need to reassemble it. So to reassemble it, it is actually fairly easy. You just put first you put the PCM unit in place, the largest and the heaviest part of the system, put it in place. Then on top of it, you slide the heat pump. So you need to have at least 2 to 3 people to lift this heat pump, just to be in line with the maximum weight that can be lifted per person. And then it will just slide in place. You just need to bolt it in place and then do the water connection and electrical connection, which will give a guidance for that if it is required in this project, or we will do it because we'll also be on site with the demonstrator. And then finally, the last part is the AHU unit, which just slide on top, and then there is nothing else to do except connecting the power supply for the fan and the sensor connection. So this is in the case of a disassembled unit that needs to be reassembled. A few more information as well about the installation process. So here you can see the back of the system, where you have the different inlets and outlets related to the district hot water, the radiator, or the water main supply. So normally those will be labeled in the system, so you shouldn't do any mistake on it. Just make sure and double check that this is properly installed, as this, if it's not properly installed, it could cause damage to the heat pump. In terms of the air, so for the air system, as mentioned earlier in the project, we have a few settings, and that has already been fixed depending on the demo. But you can see here the different air extraction from the house, supply to the house, supply from the outdoor, and exhaust to the outdoor. So just make sure that you're familiar with those two options and that the connections are properly made. For the connection to the power, so we have different sensors that we might need to use in the property, but I think this is something we already discussed with the DCs, and that may not be applied. But in terms of the power supply, so the power supply, the electrical panel is located at the bottom here. You do need to remove the front panels of the system on the side and the front, but when you do the reassembly and installation, those panels needs to be off and those needs to be removed from the system anyway. You remove the front panel and then you'll be able to access the electrical panel with the power supply connection, so the single phase 32 amp. Once this is connected, close the panel, and then we'll go through the commissioning procedure once the water and also the air supply is connected. So yes, this is just to show you where the ID plate of the system is. It's located on the top on the AHU, and I think there is one also in the lower section of the heat pump at the front. The main cable connection, 32 amp, this is very important that we have this type of supply to the system. The heat pump runs on 1.5 kilowatt compressor. 1 kilowatt compressor, 1 to 1.5 kilowatt compressor. If we add the fan on top of this, we are above the 13 amp limit. And also we have a backup heater that we might need to use in some situation that will take the totality of the power consumption of the heat pump to about 3 kilowatts. But this might not happen in some of the site, but we need to have a backup just so the end user doesn't lose the use of heat during the project. So it's more a safety measure to make sure that the tenants remain comfortable, even though we are within a research project. In terms of the commissioning, so I have identified a different step for the commissioning where we need the support of the end user. So for the pressurization of the district hot water and the radiator loop, so we'll need the support of, so this needs to be done by the end user. Powering the system up, that will be done by Ventif when we are on site. And again, similar with the booting of all the components, we're going to go through a water circulation test where we can also remove all of the air inside the radiator. We're going to test also the airflow operation, check how much pressure drop we have in the system so we can set up the velocity of our fan to the proper value. We'll close the refrigeration unit and then we'll engage what's called the PCM mode. So we'll start filling up the PCM with heat. So the system is ready to be used afterward. So we'll take the PCM to the 57 degree temperature, 58 degree temperature, and then we're gonna record those data. We're gonna check that the data are in line with what we're expecting. And then we'll do a radiator test where we'll test more like the radiator aspect of the heat pump. If we manage to get all of the values within our expectation in the project, we'll engage the auto mode, which basically will be just an input from the end user. So set up the temperature at 18, 19, 20 degrees C, and then the heat pump will automatically do its job and start operating. We also have a remote operation mode, which can be not requested, but the end user can tell us if there is any issue and we can fix it directly through the remote access. In terms of health and safety, so I identified a few ones that are quite important. So the first one is the slip and trip, being of the installer, the visitors, the DC technology provider, and also the system. It's related to the system. So we need to make sure that there is no debris along the road from the delivery site to the installation site. And we need to ensure that proper PPE are worn. So we're talking about gloves, mainly gloves, and also safety shoes is vital for the movement of this system. And yeah, so that's the main one that needs to be installed, that needs to be kept. In terms of gas safety, so there is a risk of, because we have R32 in the system, it's not pressurized that much. Even if it's released, it's going to be released in a contained environment. But ideally, we don't want that to happen because we have to ship another unit. And we don't want to do this. So the refrigeration casing, please ensure that there is no damage to it. When you receive it on site, take some photos and send us the photos so we can ensure as well for your own benefit that there is no damage that was done by the end user. Do never open the refrigeration casing. The only time the refrigeration casing can be open is when the Ventif employees are on site with the installer. Pressurized equipment, similar. So if there is a risk, because there is a risk of pressure release, we advise that whenever people are working around the heat pump or on the heat pump is to wear safety glasses and gloves to protect from projection, and also wear safety shoes and safety shoes. That's really the main thing. And ensure also that the area around the heat pump is clean, so free of trip or anything like this. In regards to electric shock, I am sure that the demonstration will have very qualified installers that can handle the electrical supply. And then the handling, which is related to the slip and trip, really. Proper PPE needs to be worn, so safety shoes, safety glass, and safety gloves. And ensure that the environment around the heat pump and the travel from the delivery to the location is clear of any issues. And finally, crash injuries. It's very unlikely to happen, but again, this is all related to the proper selection of the tools to take the heat pump from one place to the other. Normally, if the assessment is done properly, there is no issue at all of that happening. However, we registered it as a risk because it is likely, well, very, very unlikely, let's say, but it is a possibility. So what we implemented to prevent that is that we have a very low center of gravity, so we prevent any tipping during transportation, which is very important because all the PCM is located at the bottom. And finally, during transportation, please ensure that there is no pressure that is applied at the top of the unit, anywhere close to the top or the middle section. If you need to push the unit or move the unit in any way, push it from the lower section where the PCM is, and that will prevent any risk of tipping. And yeah, that's all for me.